So welcome students. Our topic for today is measures of dispersion. What are the measures of dispersion? The prerequisite is you should have clear concept of measures of the central tendencies. And what are the central tendencies? Mean, median, mode, geometric mean and harmonic mean. So these are called the measures of central tendency. You should have clear concept of these terminologies or these measures, and secondly you should have the formulae of these measures at your fingertips. Then you will be able to understand measures of dispersion and compute measures of dispersion. So revise it from your book, or you can go to my earlier videos. I have discussed measures of dispersion in detail. I have discussed mean, median, mode, GMHM, all the methods of computing mean, median, mode. So I advise you to go through those videos and understand them well before starting with measures of dispersion. So let's start our study. What is measure of dispersion? See, when we have a data, let's say we have this data 2, 4, 6, 8, 10, 12 and let's say 1 also. Let's say we have this data. We know that median is this because 3 data is to this side and 3 to this side. 6 lies exactly in the middle of this distribution. So this is median. This we know. We want to see what is the median, then what is the mean, then we'll add all of them and divide them by 7. That will be mean. Then we know what is mode and everything, geometric mean and harmonic mean. What they tell us? They tell us that the data is centered around this. This is the point where the data is centered. Let's try to visualize it. We have a line. The data is distributed along this line. Okay? Measures of central tendency tell you about this part, that the majority of the data or the measures are centered here. This is measure of central tendency, but the data is also over here. Let's assume this is a bench. Let's say this is a boundary wall over which people are sitting. So there may be 1 or 2 people sitting here, then we have 3, 4, 5 people sitting here, maybe many people are sitting in the middle, and we have someone sitting here, someone sitting here. So if you take the average, you will find something around this part. If the total number we add and divided by n, this will be mean. Median will also be around this region only, and mode will be around this region. So when you have central tendencies, the measures of central tendencies, you actually get the picture of this part. But we have data here also and here also. That is, the data is scattered throughout the first and the last available data. So that scatteredness is basically dispersion. Dispersion means scatteredness. The data has some variability. It varies from here to here. So when we study measures of central tendency, we study about this. Where is the data centered? And when we study dispersion, we study this part, the variability part. How much it is dispersed from its central values. That is what we study in the measures of dispersion. What we will study? What is the scope of our study? First, we will study what is range. Second, we will study what is quartile deviation. Then we will study what is mean deviation. And finally, we will study standard deviation. Let's see how many of these topics we are able to cover in one video. But what I'll do, I'll explain. These are very small concepts. This and this, mean deviation and standard deviation, this is the main topic. So what I'll do, I'll explain to you each and every topic, and along with the topic I'll give some examples. I'll solve some examples so that these measures are very clear in your mind. So let's start with first topic, that is range. What is range? This is a topic which we use almost every day in our usual talking. So let's start with the first measure, that is range. What is range? Every day we use this term, like we say my range is now very limited, I cannot go beyond 4 kilometers while walking, or we say the range of this missile is this much, 1000 kilometers. Range is actually if we in terms of statistics, in pure mathematical statistical terms, let's say we have data, we have n number of observations, then we have one value which is the lowest amongst these n number of data. We'll have one value which will have the lowest value, and we'll have one observation which will have the highest value. So the highest value minus the lowest value, that is called range. So if we have data x1, x2 to xn, we say it xi, and let's say the highest value is xh and lowest value is xl, then the range is xh minus xl. Simple. So for example, let's take an example to understand how this is not a very tough concept, but let's take an example. Let's say we have these data 1, 2, 4, 6, 8, 10, 12, 50, and we have to find the range. What will be the range? Range will be the highest value, that is 15, minus the lowest value, that is 1. So this is 14. So this is the range. Like we say the range of certain missile is 1000 kilometers. What it means? It means if fired from 0 to 1000 kilometers, it can go from 0 to 1000 kilometers. This is range. Practically it's not from 0. Every missile has certain limit, minimum range also. So if certain missile, let's say its range is, minimum range is 5 kilometers and maximum is 1005, so the range is 1000 kilometers. So this is about range. This is very simple concept. Now second topic that we'll understand is called quartile deviation. The second topic is quartile deviation. This is the second measure of dispersion. You all have studied quartiles at your school level in class 7th, 8th, 9th. What is quartile? I'm briefing you what is a quartile, then we'll see what is quartile deviation. Or let me say, quartile deviation Q is given by half Q3 minus Q1, where Q3 and Q1 are the third and first quartiles respectively. What are quartiles? Let's say we have a certain number of observations, 1, 2, 4, 5, 6, 7, 9, 10, 11, 12. Okay, which is the median? We have, this is the median, this is median. We have 4 data to this side and 4 data to this side. If we start from here to the median, then the median in between this is called the first quartile. So let's say this is our range, then median for this will be 4. So this is quartile 1. Similarly, the midway between this, the median bit of this is 10. This is called Q3. This is the third quartile, 75%, 25%. So this way we find quartiles. So if we have this data and we have to find the quartile deviation, Q will be equal to 1 by 2 Q3. Q3 is 10 minus Q1, that is 4. This is 6 by 2, that is 3. So the quartile deviation is 3. So this tells us about it gives an idea of the scatteredness of data. If we had to find the range of this distribution is 12 minus 1, that is 11. So 11 is the range. Now we get quartile deviation as 3. So we have narrowed down. So this is how we find quartile deviations. These two methods, range and quartile deviations, these are very simple methods, but they are not very reliable. Quartile deviation is somewhat better than range, but these measures are not for sophisticated mathematical analysis. When we do mathematical analysis, we actually use mean deviation and standard deviations. These are very crude methods, very simple methods, but these we need to understand so that we are able to understand mean deviation and standard deviation. Okay.